Dear ladies and gentlemen, my name is Elias and I'm working in the Industrial IT department of Simpelkamp Logistics and Services. We are happy to welcome you on our first webinar. Today, we want to answer how machine learning in the wood-based panel industry establishes online quality control of board properties. But first, let me introduce you to our technical expert, Bernd, who will share his expertise with us. He has more than 20 years of experience in this field, and I have the pleasure to moderate today's session with him.
Thank you, Elias. I'm happy to be here and I'm looking forward to discuss the importance of machine learning for wood-based panel production manufacturers.
Now, before we start talking about sophisticated industrial IT solutions, I would like to share the state of the art with our audience. So Bernd, let me ask, how does board quality measurement work today for most of our customers?
In order to guarantee the quality requirements of the product, it is common practice to check the product at defined intervals during the production. For that, a lab cut is made or a complete board is rejected from the cooling and stacking line. This test board is handed over to the laboratory of the plant. After a defined conditioning phase, several test blocks are cut out of the test board. The test blocks are now measured and weighed to determine the bulk density. In the further course of the process, these test blocks are tested in test machines for further quality characteristics, such as internal bond, bending strength, and so on. This is made in a destructive process. As a result, the customer has knowledge of the quality of his production at this time. But this is the state of the production from a few hours ago. In the meantime, some things may have changed in the current production and are not considered in this quality view.
I see. What does that mean during daily operations if manufacturers only know product quality parameters of several hours ago?
In order to keep their production process stable, they need to use more raw materials than needed to ensure a high safety margin, or they are having a high risks of waste boards.
Okay. Let me summarize in simple terms. So most manufacturers only know their board quality parameters from what they have produced several hours ago, because conservative laboratory testing with all its steps, cutting, gluing, testing, takes several hours, and therefore their live production parameters are unknown estimates. That means manufacturers need to use more raw materials and energy than needed, or they have the risk of process instability or waste production. About how much more are we talking? I mean, how much resources are actually wasted?
Well, we're collecting plant data from all over the world and on average, customers that use our system correctly have savings of 500,000 euros per year for each line.
Wow, that's a lot of money that customers who don't use our system leave on the table. So what solution does Simpelkamp's Industrial IT department offer for this problem in order to increase production performance?
We have developed ProtIQ Quality for more than 20 years, an online quality control system based on machine learning. It gives accurate information about quality parameters of current product and is already installed in more than 35 lines.
Before we go into the technical part of the topic, I would like to mention the key benefits of the ProtIQ quality system. Knowing live values of density, IB, and MOR for all boards that are produced without any time delay enables manufacturers to break all production performance records. Because manufacturers can bring light into their quality limits in a way that they can systematically decrease density up to 14 kilograms per cubic meter or reduce the amount of glue usage up to 7 kilograms per cubic meter. This leads ultimately to a lower cost of production, less waste boards, and transparent production stability. As Bernd said earlier, this can make on average a difference of 500,000 euros per line yearly. That's exciting and a real performance boost. Okay, Bernd, now let's dive into the technical part. How does online board quality control work, and what does it have to do with machine learning?
Machine learning is a generic term for the artificial generation of knowledge from experience. An artificial system learns from examples and can generalize them after the learning phase is over. For this purpose, algorithms in machine learning build a statistical model based on training data. This means that the system does not simply learn the examples by heart, but recognizes patterns and regularities in the learning data. Finally, the system can also evaluate unknown data. Using machine learning in a modern wood-based panel production allows you to integrate online prediction for several quality criteria in an easy and comfortable way. The main benefit is a quality monitored production for the customer at all times.
Thus, the product quality system builds patterns between process data and actual board quality results in a way that manufacturers exactly know what they're producing in terms of IB, density, and similar, instead of waiting for laboratory results, right?
Yes, indeed.
Which data does the product quality system exactly need for machine learning?
First, material flow tracking is a core component of ProductQ and a basic requirement for online quality forecasting. The idea is to report the history production data of the ready produced board at the end of the production. Let me show you this step in more detail. ProductQ records all production-related process data points over all production areas with its online data acquisition. An integrated free configurable algorithm developed by SimpleCamp allows that each production plant can be modeled in a specific production flow. Exact linear distances between measurement points, volume of bunkers and so on, are considered, and together with current process value, like material speeds and discharges of the machines, the system calculates the best possible processing time for currently produced boards. As a result, a board production history, that means material flow track data, is stored in the ProductQ database and is now ready to use with further algorithms. This is so far a unique data preparation in a MES system for the wood-based panel production.
Okay, that sounds amazing. I assume there is more data needed and collected to train the product quality system. What about laboratory data?
Yes, with the material flow tracking, we have the complete process information for produced boards available. But in order to show a relationship to board quality, the ProductQ system also needs the test results from the lab. A second important data source are therefore the quality results of a test board which are measured in the lab. As mentioned before, the board is checked in the lab. The results are used to complete the learning data record. There are several ways to import the data from the lab. I like to mention only the most important here, the automatic lab import. Usually, it is possible to define interfaces between the lab measurement or ERP system of the customer. That will allow to import lab information as soon as available automatically to update the ProductQ database. Finally, we have a complete dataset to work with.
Just for my understanding, and in order to clarify for our audience, in summary, we need material flow data for a certain board type and the respective automatically imported laboratory results in order to train the intelligent ProductQ quality system. Great. Well, that's a lot of data. We can call it big data. How do we use this data to learn more about board quality parameters?
We use this data to analyze the production. Let me show you an example. We like to develop a quality prediction. That means we create a model for the internal bond average for our 18 mm board production. With the measures described above, we already have access to learning data from history in the ProductQ system. So we are able to analyze the relationship between the individual process values and the resulting board quality. To show this in more detail, I give you a short insight in our modeling tool called Quality Manager. To start modeling, I select the 18mm board production. As you can see, we have 680 datasets recorded in the past for this production. For a next step, I select and load a prepared demo model shown in this selection box. The model is loaded now, and you see there are 3 quality criteria inside, even the internal bond average. Let us focus on this criterion. As you can see, there are 13 parameters selected on the model to describe the internal bond.
Okay, does that mean that with this selection the system achieves a mean prediction error of only 3.28%?
Right, the mean value is calculated from 10 realistic test predictions that you can see in this view. Furthermore, you can evaluate the individual prediction and you get a detailed information. For example, the prediction with the smallest and the biggest error is highlighted.
Okay, and what other information can I get about the prediction reliability?
Some more interesting characteristics, like the maximum prediction error, correlation coefficient, and the necessary safety reserve for the production.
Ah, I understand. Is this the final result, or is it possible to improve this prediction accuracy?
Well, Elias, I expected this question. And to show you an answer, let's give it a try. As you know, the spray flow on the mat forming belt has an influence on the quality. I add this parameter to the model and recalculate it.
Ah, wow! The prediction gets better!
Yes, a slightly better value in the mean prediction error, but a good improvement for the maximum prediction error.
Oh, looks fine. So does that mean we have now a model which allows an online prediction for the internal bond with a prediction error of only 3.2% in the mean?
Yes, and if you start your online prediction at your plant, you will get an online forecast with nearby accuracy in your production, because the model is proved by realistic data already.
Okay. Is it possible to have more than one quality criteria, like density or MRR in the model?
Of course, the model is not limited to one quality criteria. It is possible to add further criteria very easily.
Perfect. By the way, Bernd, how can the system adapt to different environmental situations, like different temperatures in different seasons or different raw materials?
That is no problem. The system will automatically adjust to the new situation by importing new lab test results and process values.
Wow, that's amazing! So we select our quality measure parameters, like internal bonds, in this case, and our customers can improve the model with their technological know-how and our guidance. In that way, we enable our customers to build models for all their board types. EA, they can predict, for instance, the internal bond of their current production with more than 95% accuracy. Okay, so now that we can predict our quality parameters with the established models with more than 95% accuracy, what can we do with that information to boost production performance?
If you know your quality for your current production, you are in a comfortable position to evaluate the process and change production settings if necessary. 2 situations are possible. The production is running too bad, you can't guarantee your safety limits, and you need to improve your production very quickly, or the production is running too good and you miss the opportunity to save money and resources.
How can the ProductQ quality system show me this?
Let me show you the operator's view. This program within ProductQ Quality is called Spock View. If a production is running, for which you have created a prediction model before, you can use certain information to improve your current production. The screen is divided into 2 parts. On the right side, you have tachometers for each quality criteria for a direct view on the quality, and on the left side, you see the quality trend for a historic view. You see the blue line shows your quality limit of the production what you like to guarantee to your customers. The red line is the quality currently produced. And have a look at the green line. This shows your optimal production level. That means producing at this level guarantees the quality limit with optimal material and energy usage. In our example, you have the possibility to improve your production.
So in this case I have option 2, where I can clearly see that my internal bond average is higher than it should be because I know what I'm actually producing includes more wood or resin than necessary. What would be the next logical step for a professional operator? Since we found out that the current internal bond is leading to performance inefficiencies.
Whenever the production level is too high, the operator can talk to his team and they can start reducing systematically the mat weight or resin amount until the internal bond value, in this case, is closer to the line of optimal performances, which guarantees the requested board properties.
So I am actually able to adjust production and increase performance because I know my current internal bond, instead of waiting several hours for current production laboratory results. What an advantage! That was a lot of information I would like to summarize for our audience into 7 key takeaways. All in all, we have a system that 1. Brings light to the quality parameters between laboratory testing intervals that are made every couple hours. 2. It does so by collecting material flow data, e.a. process values related to the history of the board type, and importing laboratory results automatically into the ProdIQ system. 3. These datasets are then used to select the best process parameters and create models that can predict production outcomes with quality criteria like internal bond and density with more than 95% accuracy. 4. Having this information shows operators performance inefficiencies, and they can adjust the production process by adding or saving resin and wood. 5. The procedure to select the best parameters for the model can be challenging. Therefore, it needs to be guided by technological experts. 6. To solve this, we offer our ProdIQ system with a subscription model that connects our team with customer teams and guarantees consulting assistance and constantly satisfying results. 7. In that way, future-oriented teams that start to invest into the proven ProdIQ quality system will benefit from a stable production process at all times, have less waste boards, and increase production performance. This leads on average to yearly savings of €500,000 for each line. That's really a high-end solution for manufacturers that are looking for being the best in their game with our digital game changer.